but it's necessary to understanding the for example the overall function of these protocols. And from this video we can start talking about the TCP/IP. Step by step we will learn about the TCP/IP. What is the TCP/IP? Don't forget that a user doesn't learn about the TCP/IP and doesn't need to learn about the TCP/IP because the users only use the networks. Okay, only the users should connect to networks to their work, and they don't need to think about the rules of the networks, what is happening in the background of the network. It's not important for user, okay, but it's important for us because we are administrators. Don't mistake the difference between the user and administrator. You will be one administrator, not only a user. Because of that, it's one of your important jobs is understanding the models of communication, the rules, the standards. One of the most important of these standards is TCP/IP. I will talk about the TCP/IP step by step. First, I'm going to talk about a little about the history of the TCP/IP. What is the role of the TCP/IP? After that, we can step by step learn more than this about the TCP/IP. Don't forget, if you will be a CCIE, for example, CCIE, you will again they should learn about the TCP/IP. TCP/IP doesn't complete, okay, until infinity. You need to learn about the TCP/IP more and more, but in one time you learned about the TCP/IP in level of CCNA, in next time level of CCMP, and then level of CCIE, and maybe more than this. Okay, let me to talk about the TCP/IP a little more, but I'm going to start with the TCP/IP first with the historical view. What is the TCP/IP? Okay, what is a networking model? You know that. Let me write here. Here I can write the TCP/IP because I'm going to talk about that. TCP/IP. TCP/IP is a networking model. The first things that you should know is that what is a networking model? Why we need a networking model? A networking model, maybe we call it networking architecture or networking blueprint. Okay, a networking model, sometimes also called either a networking architecture or networking blueprint, refers to a comprehensive set of documents, and individually each document describes one small function required for a network. Collectively, these documents define everything that should happen for a computer network to work. Some documents define a protocol, which is a set of logical rules that devices must follow to communicate. Other documents define some physical requirement for networking, okay? For example, a document could define the voltage and current levels used on a particular cable when transmitting data. Let me to give you some information about the function of a protocol or, for example, networking model, but it doesn't matter that all of the things that I'm going to talk about that is exactly correct, okay? Because here we are only introducing the networking model. Look at here. You know that I'm sure that you worked with the, for example, a web browser. When you are opening your web browser, okay, web browser in your personal computer, this is a web browser of your computer, and for example here you are typing www.google.com. Okay, what is happening? After some second, here you can see the home page of the Google, for example, Google. Okay, and what is happening in the background? Okay, many things is happening. For example, you know that we have a protocol, we call it HTTP. Okay, the HTTP should send your request. You will learn about the detail, don't worry about the detail, but let me to say that the HTTP should send your request to a web server. The web server contain the web pages, okay, for example Google web page or some other web page. Okay, your request should be sent to the web server, and then a web server can understand the HTTP because the web server learns about the HTTP before. After that, it can send your, for example, home page or Google home page to you. Okay, and also here we have another communication. For example, we need to forward the traffic to the destination. We need to address the traffic. We need to segment the traffic, because in some cases this home page has for example, a many components, and the size of the home page is more than only one packet. Because of that, we need to segment it. Because of that, we need some protocols. Here we are using some protocols, some rules for communicating between the PC, okay, and the web server. Because of that, these protocols can obey from different models. For example, the model that we are using now is the TCP/IP, but in the old days we had another models. Let me to give you some a history about these models. After that, we can better understand the function of the TCP/IP. Don't forget that learning of the TCP/IP is not occurring only in one video or in one course. You need to learn the TCP/IP step by step. Okay, let me to talk about the history of the TCP/IP, the history leading to TCP/IP. You know that today the world of computer networking using one networking model, almost one networking model, and that is the TCP/IP. I'm sure you heard about the TCP/IP. However, the world has not always been so simple. Once upon a time, networking protocols didn't exist, including TCP/IP. In some days, in the for old days, we didn't have the TCP/IP at all. We had another protocols. Vendors created the first networking protocol. These protocols supported only the vendors' computers. For example, IBM, the computer company with the largest market share in many markets, back in the 1970s and 1980s, published its System Network Architecture, or SNA networking. Let me write here. The first model is the IBM model. This model only is worked in the IBM products, IBM networks. We called it the system. Let me write here, System Network, for example, architecture. This is only a history, because in these days, today's, we don't use and we don't see the system network architecture model or SNA model in our networks. The SNA is equivalent of the TCP/IP in the old days, and this is only worked in the IBM products, not in other products. Okay, this is published in this model is published in 1974. Okay, old days. Other vendors also created their own proprietary networking model. As a result, if your company bought computers from 3 vendors, network engineers often had to create 3 different networks based on networking models created by each company, and then somehow connect those networks, making the combined networks much more complex. Okay, let me to see you one diagram. You can better understand with this diagram the old days of the networking, about the networking model. Look at this picture. This picture can shows the general idea of what a company's enterprise network might have looked like back in the 1980s, before TCP/IP became common in enterprise networks. As you can see here, we have IBM network, we have DEC network, we have other vendors networks. Assume that you have a company and you bought some devices from IBM, some devices from for example Digital, and some devices from other vendors. You need, okay, now you need to create 3 networks or 4 networks or 5 networks, and after that you need to, for example, connect these networks to each other. Maybe in some cases you will encounter with some problems or some complexities, but this is a view of a network engineer in that days. And as you can see here, we have many problems because this is so complex that we are working with different rules. In IBM networks, in IBM SNA architecture, we had different rules, we have different protocols. Also in DEC, we have different rules, different protocols, and also in some other vendors. Although vendor-defined proprietary networking models often worked well, having an open vendor-neutral networking model would aid competition and reduce complexity. Okay, you know it. Assume that all of these vendors are agree about their some rules, and they can use only that rules, and this is so useful for a company that for example bought different products from different companies such as today's, and they are working together. Because of that, we had two efforts to creating a vendor neutral networking model. The first from the ISO, or International Organization for Standardization, in the late 1970s, and finally this effort led to the creating the Open System Interconnection, or OSI model. And the second less formal effort related to the Department of Defense, or DoD of the United States, to creating the networking model. We call it TCP IP. Let me to write here. We had two efforts in the same time. Look at here. The first is the ISO's effort. Finally, it's created the OSI, or Open System Interconnection model, and the second DoD, Department of Defense, the defense, that the result of this effort is TCP IP. As you can see here, in the 1990s, during the 1990s, companies beginning for example, adding OSI and TCP IP, or both, to their enterprise networks. However, by the end of the 1990s, TCP IP, as you can see, had become the common choice, and OSI fell away. As you can see here in this picture, we have only TCP IP, and in the here in the 21st century, TCP IP dominates. Proprietary networking model still exists, but they have mostly been discarded in favor of TCP IP. The OSI model, whose development suffered in part because of a slower formal standardization process as compared with TCP IP, never succeeded in the marketplace. And TCP IP, the networking model originally created almost entirely by a bunch of volunteers, has become the most prolific network model. Because of that, we need to learn about the TCP IP, but in many cases we are referring to OSI. Now the OSI